Okay, I'm making this for those of you that need a little bit more than just seeing the answers. This first one, remember I rewrote it the other way. I divided both by -1, which meant I needed to switch the inequality symbol, giving me the answer x is greater than -5. So I'm showing my solution here, all numbers greater than -5. The next three are pretty basic. You're just using order of operations. Remembering with this fraction, it's -1/2 times x, so you have to multiply by the reciprocal, so -2 on both sides. Here, some people were thrown off because you ended up with a fraction. Remember, many times you end up with a fraction. It's okay. So I added 5x to both sides because there are variables on both sides of the inequality symbol, so I got rid of whichever was my least to get me this, and then I just used inverse operations. Here I needed to use the distributive property first. So if you didn't get this answer, check to see if you used the distributive property correctly. Added 8x to both sides and solved from there. Alright, starting in with the compound inequalities, a couple things that you need to remember. Open circle is not an equal to, so this is less than, where the closed circle includes that number, so it is a greater than or equal to. Since these are going in opposite directions, it is an or compound inequality. So x needs to be less than -6, or it could be greater than or equal to 2. When you're solving compound inequalities, remember you have to solve each part. So for 6, just like equations, there are going to be some inequalities that just don't make sense once you solve them. So in this case, it didn't make sense. This is what I came up with. So once I did all the solving steps, and you can't have x is greater than 0 or x is less than 1. If this had been an and, it would work, but as an or, it does not work. So you need to point that out. So here's another solving. So doing the distributive property first, and then solving each part. This is an and, so I just left it together. So I divided everything by 2, and then subtracted 1 from each part, divided by -3. And since it was dividing by -3, I had to flip, and I actually flipped everything all at the same time. So you probably have it written first. -1/3 is greater than x is greater than -4/3. I just went from here to here. And 8 is the solving the absolute value inequality. So the first thing I look at is this sign right here. Because it is a greater than or equal to, or maybe it was just a greater than, I can't tell on here if it's an or equal to, but anyway, it has to be an or. So if it's greater than, or equal to, it has to be an or. If it is a less than or equal to, it has to be an and. So here I rewrote it. I took this that's inside the absolute value, put it greater than 9, and if it's a, I'll just put this here just in case it is a or equal to. And then I took what was in the absolute value, took it out, and reversed the sign, and reversed it to its opposite. And then I solved each part and left it written as an or. So again, absolute value inequalities, greater than or equal to are ors, less than or equal to are and inequalities. I'm not going to go through the entire 9 because it is very similar to 8. A couple things I want to point out though is the absolute value was not isolated. It wasn't on a side by itself. So before you put it into a compound inequality, you needed to isolate it by subtracting 2 on both sides. And then it was a less than, so you needed to write it as an and compound inequality. So you're going to take whatever's in the absolute value, drop it in between less than symbols. The positive 7 is on one, the negative 7 is on the other, and then solve till the end. Alright, starting with application problems. So don't, especially with these first ones, think through it logically. If you are considered an adult at age 18 and you want to buy a junior ticket, your age has to be less than 18. And I indicated to use an A, but I know many of you like using X's. That really should have been an A. All right, second application problem. The cost to get into the Valentine's dance is $5. You can purchase carnations for $1.50 each. So let X be the number of carnations, because it says, write an inequality describing how many carnations you can buy if you only have $23. So here, this part indicates what you have to spend, and this is what you have to spend. So you can't spend more than what you have. So we're just going to, so here it starts at 5 and you go up 150 for every carnation, and then you solve that inequality. So I came up with X is less than or equal to 12. So for what number of friends could you buy carnations? Well, it didn't say what is the maximum. It said for what number. So it's 12 or fewer. You might decide that you only have one person that you want to buy a carnation for. So it's 12 or fewer. Again, the limit would be 0. So if you wanted to add that in there, you can't buy negative flowers. So it'd be between 0 and 12. All right, and this last problem we actually did in class. Remember, for this one you were given 2 data points for whole milk and 2 data points for low fat. One of the data points was the y-intercept. So you needed to use the data points to find the slope, and then you could write the expression about whole milk, and you could write the expression about low fat. And we wanted to know when low fat was going to exceed whole milk, when that consumption was going to exceed whole milk consumption. So we solved the inequality and came up with something X needed to be greater than 8.2. What this tells us is that sometime in 2008, low-fat consumption will start to exceed whole milk consumption. So my answer, written very sloppily, low-fat will exceed sometime starting in 2008 through 2010. I didn't go any further than that because our story was just about 2010. Hope that helps.